Hello everyone, this is Dr. Aparna, Head of the Department of Mathematics and Management Sciences. Today I am going to explain Lagrange's mean value theorem and applications. Lagrange's mean value theorem is used in motion analysis, error estimations and optimizations. The statement of Lagrange's mean value theorem is f of x is continuous function in closed interval of a comma b. Second point is f of x is differentiable in open interval of a comma b, then there exists a point C belongs to open interval of a comma b such that f dash c is equal to f of b minus f of a by b minus a. This is the statement of Lagrange's mean value theorem. In Lagrange's mean value theorem, the given function must be continuous function. F of x is differentiable function. Suppose the given function f of x satisfies these two conditions, then we are going to calculate the value of c by using the formula f dash c is equal to f of b minus f of a by b minus a. By using the definition, we are going to calculate f dash c value. Application problems. First, verify Lagrange's mean value theorem for the function f of x is equal to x cube minus x square minus 5x plus 3 in the interval 0, 4. Here, given that f of x is equal to x cube minus x square minus 5x plus 3. Clearly, this function f of x is a polynomial function. We know that every polynomial function is continuous and differentiable. So, therefore, clearly, f of x is continuous function in the interval, closed interval of 0, 4, and f of x is differentiable in open interval of 0, 4. So, here f of x function satisfies all the conditions of Lagrange's mean value theorem. Therefore, Lagrange's mean value theorem is applicable for the given function. According to the statement of Lagrange's mean value theorem, f dash c formula is f of b minus f of a by b minus e. Here, a value is 0, b value is 4, given that a is equal to 0 and b is equal to 4. Here, f of x is equal to, the given function is x cube minus x square minus 5x plus 3. That implies Derivative of f of x is denoted by f dash x, that is d by dx of f of x. That is equal to d by dx of f of x is x cube minus x square minus 5x plus 3. Now d by dx of x cube is 3x square minus d by dx of x square is 2x minus 5 into d by dx of x is 1 plus d by dx of 3 is 0. That is equal to 3x square minus 2x minus 5. Therefore, f dash x value is 3x square minus 2x minus 5. Now, f dash c is equal to 3c square minus 2c minus 5. This will come by substituting x is equal to c in the previous step. But f dash c formula is f of b minus f of a divided by b minus a. Therefore, substituting f dash c value in this, we have 3c square minus 2c minus 5 is equal to f of b. Here b is 4 minus f of a is 0 by b minus a, 4 minus 0. So, simplifying, we have 4 into 3c square minus 2c minus 5 is equal to f of 4 minus f of 0. Take it as this is equation number 1. Next, we are going to calculate f of 4 value from f of x. But f of x is equal to, here f of x is equal to x cube minus x square minus 5x plus 3. Therefore, f of 4 is equal to, by substituting x is equal to 4 in the previous expression, we have 4 cube minus 4 square minus 5 into 4 plus 3. Simplifying, we will get f of 4 is equal to 31. Next, by putting x is equal to 0 in f of x, we will get f of 0. f of 0 is equal to 0 cube minus 0 square minus 5 into 0 plus 3. Finally, f of 0 value will be equal to 3. Here, f of 4 is 31, f of 0 is equal to 3. Substituting f of 4 and f of 0 values in equation 1, we will get the next step. Therefore, 3c square minus 2c minus 5 is equal to f of 4 minus f of 0 divided by 4, that is equal to f of 4. Here f of 4 value is 31 minus f of 0 value is 3 divided by 4. Therefore, finally, we will get simplifying 3c square minus 2c minus 12 is equal to 0. Simplifying this equation, we will get the value of c. So, this is clearly represents a quadratic equation is of the form ax square plus bx plus c is equal to 0. The roots of this quadratic equation can be calculated by using the formula x is equal to minus b plus or minus square root of b square minus 4ac by 2a. Here we have a value is 3 by comparing b is equal to minus 2, c is equal to minus 12. Substituting and simplifying, will get x is minus b. Minus b is equal to minus 2 plus or minus square root of b square minus 2 whole square minus 4a into c is minus 12 by 2 into a is 3. Simplifying, finally you will get the value of c is 1 plus or minus root 37 divided by 3. After simplifying, we'll get the value of x. X is like this. This is C value. This is the value of C. So finally, we'll get the values of C is equal to 1 plus or minus root 37 by 3. But C is equal to 1 minus root 37 by 3 does not belongs to open interval of 0, 4. Therefore, C is equal to only 1 plus root 37 by 3 belongs to open interval of 0, 4. Therefore, by Lagrange's mean value theorem, C value is equal to 1 plus root 37 by 3. That C value is clearly lies between 0, 4. Now I will explain the second problem in using Lagrange's mean value theorem. The statement is, if A is less than B, prove that B minus A by 1 plus B square is less than tan inverse B minus tan inverse A less than B minus A by 1 plus A square. Using Lagrange's mean value theorem, deduce the following expression: pi by 4 plus 3 by 25 is less than tan inverse 4 by 3 is less than pi by 4 plus 1 by 6. We can prove this result using Lagrange's mean value theorem. For proving this result, consider f of x is equal to tan inverse x. Tan inverse x is clearly continuous and differentiable in the given interval. Therefore, clearly f of x is continuous in closed interval of a comma b and differentiable in open interval of a comma b. There and also the given condition is a less than b. Here f of x is continuous function in the given interval and f of x is differentiable function in the given interval. Therefore, f of x satisfies all the conditions of Lagrange's mean value theorem. F of x satisfies all the conditions of Lagrange's mean value theorem. By Lagrange's mean value theorem, there exists a point C belongs to open interval of a comma b such that f dash C value will be equal to f of b minus f of a by b minus c. Dash C is equal to f of b minus f of a by b minus c. Here, f of x is equal to tan inverse x. That implies f dash x is equal to d by dx of tan inverse x. D by dx of tan inverse x is equal to 1 by 1 plus x square. F dash x is equal to here 1 by 1 plus x square. That implies f dash c is equal to 1 by 1 plus c square. By substituting x is equal to c in the above expression, you will get f dash c. Finally, f dash c is equal to 1 by 1 plus c square. Therefore, by Lagrange's mean value theorem, f dash c is equal to f of b minus f of a by b minus a. That implies, from the previous step we know that f dash c is equal to 1 by 1 plus c square is equal to f of b. f of b minus f of a by b minus a. Take it as equation number 1. We can calculate f of b and f of a values by using the given function. Here f of x is equal to tan inverse x. That implies f of b is equal to tan inverse b. And f of a is equal to tan inverse a. Putting x is equal to a and b in f of x, we will get f of b and f of a. Substituting f of b and f of a values in equation 1, we have 1 by 1 plus c square is equal to tan inverse b minus tan inverse a divided by b minus c. When you are cross multiplying, we have b minus a by 1 plus c square is equal to tan inverse b minus tan inverse a. Tan inverse b minus tan inverse b. B minus a by 1 plus c square is equal to tan inverse b minus tan inverse a. Given that c belongs to open interval of a comma b, that implies a less than c less than b. That implies a square is also less than c square less than b square. That implies 1 plus a square is less than 1 plus, adding 1 you will get like this, 1 plus b square. 1 plus a square is less than 1 plus c square less than 1 plus b square. By taking the reciprocal, we have 1 by 1 plus a square clearly greater than 1 by 1 plus c square is greater than 1 by 1 plus b square. But our inequality is b minus a by 1 plus a square. So now multiplying both sides, multiplying the above expression on both sides by b minus a, we have multiplying, we have 1 plus 1 by a square is greater than b minus a by 1 plus c square is greater than b minus a by 1 plus b square. Take it as this equation 2. From the previous step, we know that b minus a by 1 plus c square value will be equal to tan inverse b minus tan inverse a. Already this is proved in the previous stage. Therefore, b minus a by 1 plus a square is greater than b minus a by 1 plus a square is greater than tan inverse b minus tan inverse a is greater than b minus a by 1 plus b square. Therefore, when you are representing in this following way, the above expression can be represented in the following way: b minus a by 1 plus b square is clearly less than tan inverse b minus tan inverse a is less than b minus a by 1 plus a square. Therefore, this is the deduction part. This is coming from Lagrange's mean value theorem. Finally, hence it is proved. Therefore, b minus a by 1 plus b square is less than tan inverse b minus tan inverse a is less than b minus a by 1 plus b square. For proving pi by 4 plus 3 by 25 less than tan inverse 4 by 3 less than pi by 4 plus 1 by 6. For proving this result, put b is equal to 4 by 3 and a is equal to 1 in equation 3. In equation 3, we get 4 by 3 minus 1 divided by 1 plus 4 by 3 whole square is less than tan inverse 4 by 3 minus tan inverse 1 is less than 4 by 3 minus 1 divided by 1 plus 1 square. This is coming from by substituting b is equal to 4 by 3 and a is equal to 1 in third equation, we will get this step. By simplifying, we have we will get 3 by 25 less than tan inverse 4 by 3 minus tan inverse 1 less than 1 by 6. That implies 3 by 25 less than tan inverse 4 by 3 minus tan inverse 1 can be written as tan inverse. This 1 can be written as tan pi by 4 is less than 1 by 6. From this we have 3 by 25 is less than tan inverse 4 by 3 minus tan inverse tan is 1, that will be equal to simplifying, you will get pi by 4 less than 1 by 6. After that, adding plus pi by 4 on both sides, we have 3 by 25 plus pi by 4 is clearly less than tan inverse 4 by 3 is less than 1 by 6 plus pi by 4. This is the deduction part. Hence, the deduction part is proved. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.